All right, so one question you could be asked about this kind of stuff is which one of these is which. So one is iron coordinated with water, and the other is this iron coordinated with cyanide, right? So which is which? So we see these two powders, and they're different colors. The colors are going to give us a hint of what this is, right? This color is this kind of like blue-green, I guess, and this one's kind of an orange. And so think about what that means. Let's take a look at our compounds and what the differences between these two are. Cool, so each cyanide is -1, so you can see the iron in both of these compounds is actually +2. The next thing we're going to want to think about is our ligand field strength and what that means. So we find our ligands on our little chart here, and you don't have to memorize these or anything. I'll give you the chart if you need it. So water's right there, and then cyanide is all the way over here. So one's obviously stronger than the other, right? This side is stronger, or the cyanide is strong, a strong field ligand, while the H2O is at least a weaker field ligand. And then you want to think about the energy gap of strong and weak field ligands. Strong is big gap, weak is little gap, right? So, and then you have to think about what that means in terms of light coming in. Since this gap is small, this one will absorb low energy light. Low energy light corresponds with long wavelength. And then vice versa for this other side. This one's going to absorb high energy light, which means a low wavelength. And so all of these transitions kind of happen in the visible range, so that's why we can see it. So next up, we got to take a look at our color wheel and our complementary colors. Let's go with the water on this side first, right? This is going to absorb low energy light, which is long wavelength. So it's going to kind of absorb, I don't know, like somewhere around in this area. And think about the difference between what the thing is absorbing and what you're seeing. If it's absorbing this high energy light, then what you're going to see is low energy light. And low energy light, right, the opposite over here would be this kind of blue-green. And then in the other case, we have the cyanide, which is a strong field ligand. And so this is a big gap. And so it's going to absorb high energy light or low wavelength. So low wavelength will be this kind of purple-blue. And that's what it's absorbing. So it's going to release the rest of the stuff. So we look at kind of the complementary color. And it's this kind of yellow-orange area. And so thus we've identified which one is which, right? We said the water is the blue-green. So this one ends up being this water one. And then the cyanide one is absorbing the purple, so it's looking yellow-orange. And so the cyanide one is over here. So understand that the relationships between how big this gap is and the ligand field strength, what the big gap means in terms of absorption, and then what absorption means in terms of what you actually see. Remember, what the thing absorbs is kind of the opposite of what you see.